everyone, Bella here, bringing you some mission rocket science from the Estes Education studio. Today, we're going to share an experiment from our free Feel the Heat lesson plan. This is Make a Hot Pack Lab. In our Feel the Heat lesson plan, students will answer the question, how does a model rocket launch show thermal changes in a chemical reaction? They will also differentiate between exothermic and endothermic reactions and create a device that releases thermal energy. Before we get into endothermic and exothermic reactions, what is a chemical reaction? Chemical reactions require energy to break bonds of the atoms of the reactants and to create bonds in the products. When it takes more energy to break bonds than to form bonds, energy is absorbed. This is called an endothermic reaction and will cause a decrease in the temperature of the surroundings. Examples of this include frying an egg and water evaporating. When it takes more energy to form the products than to break the bonds, energy is released. This is called an exothermic reaction and will increase the temperature of the surroundings. Examples of this include a campfire or iron rusting. Now let's get to the experiment. Feel free to grab your supplies and do the experiment right alongside me. In this lab, students will experiment with different substances to discover which combinations could be used to make a hot pack. Their mission is to ultimately design a hot pack that will be used by astronauts inside of their spacesuits to keep them warm as they're exploring the surface of the moon. This is usually when I would give students a disclaimer that although they're mixing different substances, I know everything here is safe. They can't just go home and start mixing up random things because that could be very dangerous. Students are given a table with a list of different materials, liquids and solids that they could use, and then they need to make the trials and combinations of different solids and liquids to see if a temperature change has occurred. But I'm gonna make it really easy on us here today. Each trial should include 10 milliliters of a liquid and 5 grams of a solid. First, we're gonna start with 10 milliliters of vinegar and 5 grams of steel wool. First, I'm going to get the initial temperature of the vinegar. At 22.5 degrees Celsius. Next, I'm going to fluff the steel wool a little bit. I'm gonna add the vinegar and then I'm gonna wait 1 minute and check the temperature again. All right, it's been a minute. We have 23.2 degrees Celsius. So we have a temperature change, an increase of 0.7 degrees. Next, we're gonna test 10 milliliters of hydrogen peroxide and 5 grams of active dry yeast. Gonna go ahead and get our initial temperature. We have 22.2 degrees Celsius. I'm gonna take a spoon because we're gonna stir it up a little bit very gently. We're gonna go ahead and add in the peroxide to the yeast. Then we're gonna wait 1 minute. It's been a minute. Let's check and see if there's been a change in temperature. We have 36.4 degrees Celsius. So we had an increase of 14.2 degrees Celsius. So for our next experiment, we are going to combine 10 milliliters of water and 5 grams of Epsom salt. Don't forget to record your initial temperature. We have 22.2 degrees Celsius. I'm going to add the Epsom salt and stir gently. All right, next you're gonna wait 1 minute. It's been 1 minute, let's check. We have 18 degrees Celsius. So that was a decrease of 4.2 degrees Celsius. For our last experiment, we are going to combine 10 milliliters of vinegar and 5 grams of baking soda. You definitely want to stir gently for this one. Don't forget to check your initial temperature. We are at 22.4 degrees Celsius. Now we're gonna wait 1 minute. All right, it's been 1 minute, let's check. (17.4 degrees Celsius. That means we had a decrease of 5 degrees Celsius. So which combination might keep our astronaut the warmest? In the studio today, we're gonna go with hydrogen peroxide and dry yeast. It had a temperature increase of over 14 degrees Celsius. When students design their own astronaut hot pack, they'll use 10 milliliters of liquid like we did here in the studio today, but they can use up to 10 grams of their chosen solid also. I hope you had fun today learning about our free Feel the Heat lesson plan. Check the description for the link to the full lesson plan and all our other free resources. Join us next time when we answer the question of how a model rocket launch can demonstrate thermal energy changes in a chemical reaction. If you like this video, like, subscribe, and hit the bell to be alerted for new content. Happy launching!